Hello, this is a video about how to play the decay game, but mostly about how to write the decay reactions. So you and your partner have your directions. I do want you to read all the directions because I'm just going to go through this part very quickly. So I want you to understand the directions. You will also need a game board, some player pieces, your reference tables, especially table O and the periodic table, and Google Dice. So pull up Google Dice, find a six-sided die that you can roll for these various moves. Okay. Everybody is going to start here at uranium-238. I want you to notice that your horizontal axis is atomic number, also known as charge, and your vertical axis is mass number. So in isotope notation, the starting point is this. When we write our isotope, the bottom left number is the atomic number or the charge, and the top left number is the mass number. These are all going to be natural transmutations where the parent nucleide is inherently unstable. It has a specific kind of decay it wants to do, either alpha or beta in this case. There are other options, but this game board only has alpha or beta options. And then you see what daughter nucleide it turns into after it has lost that particle. So all of these equations will have only one reactant, and they'll have two products. One of them will be alpha or beta, and the other one will be whatever is left over. You can tell what kind of decay you're allowed to do by where you are on the board. If I'm here, the arrow that I can follow, the only arrow I can follow, has a little alpha sign on it. If I do the alpha, the next arrow that I can follow is this little arrow that has a beta. This is a beta, boop, just that one little step. And then this is another beta, boop. So if I go down this board, I can only move if I roll an alpha decay, then a beta, then a beta, then an alpha, 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 alpha. Once I get here, I start to have options. So if I'm on this spot and I roll either a beta or an alpha, I can move. If I roll a beta, I can go here and then continue. Alpha, maybe beta, alpha. This is where your reactions should differ from your partner, and everybody, whether you win or lose, should end up eventually at the bottom, either here or here. Okay? Lead or thallium-206, and you only stop decaying then because these guys are stable. All of these isotopes are unstable. They're trying to get more stable by releasing particles, and they do not succeed until you get way, way, way down here. So I am just going to show you the first two steps so you see how the equations go. If I'm here, I have to roll a 6 because I want to do an alpha decay, and I have to roll a 6. If I don't roll a 6, my partner rolls, we go back and forth. Finally, one of us rolls a 6. If you roll a 6, you can do the decay, and then you have to write the decay. I'm going to zoom in a bit here. Okay. First of all, what kind of decay was it? Alpha. So I go to table O, and I'm going to spit out an alpha particle. I can either write it with this little Greek letter A. Depending on how you draw this, it looks more or less like a fish. Or it can be helium. Either way is totally valid, but I need these numbers. I need the mass number of 4 and the charge of 2 in order to write the rest of my reaction correctly. So 4, 2, alpha. Okay. Now imagine that there's an equal sign on the arrow, that will help you balance the mass. The top numbers are mass. The total mass before has to equal the total mass after. So I'm going to circle a lot of things just to over dramatize this. The total mass before is 238, and it has to equal 4 plus something. Okay. You can think of it as your mass was 238 and you lost a mass of 4, and this is what's left over. But no matter what, if you put an equal sign on the arrow, and you just think of this algebraically, you will put the correct mass number right there. Okay. Now, the same with the lower numbers, charge. Total charge before has to equal total charge after. So my total charge before is 92, which of course equals 2 plus 90. Again, you shouldn't be circling these. I'm just circling them to color code them to really show you the logic of the math. Now, this is transmutation. If you change your atomic number from 92 to 90, you have done something very dramatic. You've actually changed the element, transmutation. So I have to take this atomic number 90 and go to the periodic table to figure out what new element I have become, and take the symbol TH. This happens to be thorium. Okay, so that is my first alpha. If I roll a 6, I get to move the alpha, and then I write the alpha. While I'm here, I might as well take my product and write it at the beginning of the next step. Because this guy is definitely still not stable yet. I've got a whole board to work my way down. Okay, let's see the next step. The next arrow has a little beta on it. It's my only option to move from here to there with a beta. So if I roll a 3, 4, or 5, while I'm sitting here, I can do the decay. If I roll anything else, I have to wait for another turn. Okay, so let's say I roll that, I move it, now I'm going to write a beta decay. I've already got it set up. I'm going to put a beta particle there and figure out what's left over. Here are my options for how to write a beta. The mass is always 0, the charge is always -1. I could do a lowercase e for electron, or the Greek beta symbol, which is like a B with a long tail. Either way. And then I'm going to put a plus sign here, anticipating that I'm going to figure out what's left over. Okay. The mass here is pretty easy. 234 equals 0 plus 234. You lost no mass. The charge is where you want to be really, really careful. 90 equals -1 plus, this has to be 91. Some people will say, oh, 89, but then think about it. 89 and -1, put them together, they do not equal 90. Or you can think of it as losing a negative particle. If you lose a negative, you go up. Just like in math class, when you subtract a negative, it's like adding a positive. So last thing I've got to do just is find atomic number 91 and see who I have transmutated into. PA happens to be protactinium. Okay, I've done my first 2 steps. Every time I move, I write my reaction, and I'm going to set this guy up to be ready for the 3rd step. You may or may not use every arrow here. It very much depends on the path you take on the board. Everybody's got to get to the bottom of the board, and at the end, I will check your reactions.